Okay, so a very good morning to all our poll buddies here today. So I am one of our poll leaders. My name is T. Ishan, and here is my partner in crime.
Thank you, T. My name is DHARSHINI Surendharan, and I'm one of the poll leader as well. Now I'll pass the floor to my partner T.
Thank you, Darshan. So today we'll be mainly explaining about what is aerobic respiration, and mainly we are going to be touching on the glycolysis process. So before we get into glycolysis, let me briefly introduce to you guys about what aerobic respiration actually is. So aerobic respiration is actually a type of cellular respiration that occurs in the presence of oxygen, which means that it must occur in the presence of oxygen, which means that it requires oxygen in order to occur. And this process, the function of the aerobic respiration is that it can actually release energy that was stored in the glucose and the other organic compounds in order to produce ATP for the functioning of our body. And then from aerobic respiration, there are actually 4 stages in it. And the first one being glycolysis, our main character today. The second one being link reaction, or also known as oxidative decarboxylation. While the third one being Krebs cycle, also known as citric acid cycle. While the fourth one being oxidative phosphorylation. So, glycolysis. This is going to be our main topic today. So now let's get into what actually is glycolysis. Alright, so we will be explaining about glycolysis from the naming itself. Alright, so glycolysis, the word glyco, it actually means glucose sugar. Glyco actually means glucose sugar. Well, for the lysis actually means a process of breaking down. So, glycolysis overall is actually a process of breaking down glucose sugar in order to produce what? In order to produce pyruvate and ATP, which is the main purpose of aerobic respiration, to produce ATP. Alright. So, glycolysis. What is actually so special about glycolysis? Actually, so there are actually 2 reasons why I say that glycolysis is one of the most special process compared to the other 3 stages here in aerobic respiration. So the first reason is that glycolysis, it is actually the only stage that does not occur in mitochondria, or rather, it occurs in cytoplasm of a cell. While the second reason being that glycolysis, it actually does not require any oxygen. While for these 3 other stages, all of them requires oxygen in order to occur. So that's essentially the very special thing about glycolysis. It can occur even if there is no oxygen, because the process itself does not require oxygen. So it can actually occur in both aerobic respiration and anaerobic respiration. So yeah, that's for the introduction of aerobic respiration and glycolysis. So next, I'm going to pass the floor to my partner in crime to briefly introduce to you guys about how does glycolysis actually occur. So the floor is yours, Darshini.
Thank you, T. So after a brief introduction about our main process, glycolysis, just now, I'm here to teach you the first 5 steps of glycolysis. Before we get started, let me give you some heads up. There are 10 important steps in glycolysis in order for us to produce the energy we need through glycolysis. Without further ado, let's get into the first step. So, what is the first step? The first step is phosphorylation, as you can see in our slides up there. Phosphorylation. So what happens? If you see the animations here, we have 6 carbon. So what is this 6 carbon structure called? You are right. Obviously our glucose. structure. And if you notice, we have an ATP there. ATP. Let's see what happens to the ATP and also the glucose. Let me show you the animation. See, ATP is split into two. ADP and a phosphate group. Remember, ADP and a phosphate group. But where is the phosphate in the animation? Why are we showing ADP only? Here comes the phosphate. The phosphate attached to the glucose structure. Just like this. You see, the phosphate from the ATP split and attached to the 6th carbon of the glucose. Now, we call this process phosphorylation. The glucose is phosphorylated by receiving a high energy phosphate from ATP. So, there is an important enzyme that you need to remember. Enzyme that catalyzes this step, this particular reaction is called hexokinase. Hexokinase. So, what's our product? As you can see the animation, we have 6 carbon structure, which is a glucose, and there's a phosphate attached to the 6th carbon. Now we call this glucose 6-phosphate. That's the product of the first step. Let's get into the second step. Yeah, as you can see, it's isomerization. What's isomerization? It's actually very simple. It's a very simple rearrangement. Do you remember the product from the first step? Glucose 6-phosphate. So, this glucose 6-phosphate is gonna undergo a rearrangement. Let's see how it rearranges itself. Carefully look at the animation. We're gonna show the rearrangement. Did you just see the color change? Yeah, that is how we plan to show the rearrangement through our animation. So the color change, it means the glucose 6-phosphate is undergoing rearrangement. Now what's the product for the second process? Fructose 6-phosphate. As you see, the phosphate is still attached to the 6th carbon. So we still call it as fructose 6-phosphate. Clear? Okay. Now we'll move on to third step. Okay. Third step. This is again another phosphorylation. So I'm sure you still remember what happens during phosphorylation, right? Okay. We have fructose 6-phosphate that we got from the second step. Fructose 6-phosphate, and also we have an ATP there for you. Remember what happens to the ATP during phosphorylation? Okay, let's recall back the process that we learned in the first step. ATP is split into two. What are the two products? ADP and also a phosphate group, of course. So, where is the phosphate? Okay, ATP is split and the phosphate is going to attach to the first carbon. Remember, there's already a phosphate group to the 6th carbon. Now we have another phosphate group attaching to the first carbon. What's the name of this product? We call this fructose 1,6-bisphosphate. Remember, 1,6 and bisphosphate. There are two phosphates, so we call it bisphosphate. Fructose 1,6-bisphosphate is the product for the third step. Remember, we had hexokinase for the first step? Yes. We have another important enzyme that you need to remember for this phosphorylation. The enzyme catalyzes this reaction is called phosphofructokinase. Remember, phosphofructokinase. Doesn't the name sound very related to this phosphorylation? That is how you should remember. Okay, now we are moving to fourth step. This process is called splitting of 6-carbon sugar. As the name implies, we are going to split the 6th carbon. How are we going to do that? Okay, if you see on the screen, we have the fructose 1,6-bisphosphate. This structure is going to split split now. Let's see how it splits. Ta-da! So now we have two structures there. One is called dihydroxyacetone phosphate. Wow, so long, right? We have the acronym for this. DHAP. So after this, I'll be using DHAP. Remember, DHAP stands for dihydroxyacetone phosphate. Okay, so what's the second structure? Let's see. G3P. What is this G3P? This is a simple acronym. So this G3P stands for glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate. So we call it G3P. I'm going to use G3P after this. So better bear in mind. Okay, this is going to be the last step that I'm going to explain today. The fifth step. It's the isomerization again. So you know what exactly happens during isomerization, right? Simple rearrangement. Let's see what happens. You see? Did you see the phosphate group in the DHAP moving from the first carbon to the third carbon? So what's the product formed from this isomerization? We call it G3P. Remember, we had DHAP. After the rearrangement, it became G3P. As a conclusion, until the fifth step, we have 2 G3P. Remember, we have 2 G3P structure. And after this, there are 5 more steps. Don't rush. We have 5 more steps, and it will be explained by my partner, T. The floor is yours, T.
Okay, so thank you, Darshini. So, hi guys, I'm back again. So now I'll be explaining about the last 5 steps of glycolysis. So now let's begin from the 6th step. So what happened during 6th step? So this 6th step is actually quite complicated compared to the other steps. So please stay with me and be all ears, alright? So, during this step, we actually have 2 stages. One being oxidation, while the other one being phosphorylation. So, what happened during oxidation though? And what actually is oxidation? And how does oxidation occur? So, be patient. I'm going to be explaining to you guys. So, oxidation, it actually can be explaining in a few ways. But I'm going to mainly focusing on 2 ways. One is the process of receiving oxygen atom, while the other one is a process of releasing hydrogen atom. Both of these can be called as oxidation. So, in this scenario, in this glycolysis scenario, we will explain oxidation as a process of releasing hydrogen atom. So, I hope you are clear on that. So, if you are clear on that, it should be easier for the rest of the step. So, during the oxidation stage of 6th step, our G3P, remember, we had 2 G3P from the 5th step. Our 2 G3P, each of them are going to transfer 2 hydrogen atom to what? To NAD+, which is why they are present here. Can you see the NAD+? There are actually 2 NAD+ here. Why are there 2 NAD+? Because there are 2 G3P there. Each of the G3P are going to transfer 2 hydrogen atoms each to the NAD+, forming 2 NADH and 2 H+. Let me show you guys the animation. So we have 2 NADH and H+. And that's it for the oxidation part. However, there's something that I would like to remind. Please remember how many NADH are being produced here. Because sometimes during past questions, they will ask about these questions. And sometimes they are going to ask us another question, which is, what is the role of NAD+? And it's important to know that NAD+ actually has a role known as oxidizing agent. Because oxidizing agent, to make it simple, it is actually a compound that helps to make the oxidation occur. And in this scenario, NAD+ is actually helping G3P to undergo oxidation. And that's why NAD+ is known as oxidizing agent. Alright, so let's continue to our second stage of 6 step. Alright? So, the second stage of 6 step, phosphorylation. So, during phosphorylation, remember what happened? It is going to bind to another phosphate atom, just like how my partner in crime explained about it just now. So, during this step, what happened is that our carbon sugar, which are our GGP, they are going to get bond to another inorganic phosphate. However, what is the difference compared to all the last two phosphorylations is that in this phosphorylation, it doesn't take the phosphate from ATP, but rather it is actually taking the phosphate from the cytoplasm. Remember, this glycolysis occurs in cytoplasm. So, they are actually going to take the inorganic phosphate from the cytoplasm, and they will be phosphorylated with another phosphate atom, forming a compound with two phosphate atoms, which now we call them as 1,3-bisphosphoglycerate. A very long name, right? But no worries. Let me briefly explain to you guys about how is it named. So, the word glycerate actually means a type of 3C sugar. Clear on that? Well, the word bisphospho usually means two phosphate atom. Bisphospho means two phosphate atom because bis actually signifies two. So the 1,3 actually signifies where the phosphate atoms are located. So in this case, we have 3 carbon sugar and 2 phosphate atom located, one on the first carbon atom and another one on the third carbon atom. So yeah, so that's all for the 6th step, oxidation and phosphorylation, forming 1,3-bisphosphoglycerate. So now let's get into the 7th step. So, 7th step. So at this 7th step, we are finally entering a phase that is known as energy payoff, where we are finally starting to release ATP rather than consuming ATP. Remember, at the beginning of glycolysis, we actually use ATP rather than producing ATP. However, in this step, starting from 7th step, we are finally starting to approaching our objective of aerobic respiration, which is to produce ATP. So, this process of producing ATP is actually called as substrate level phosphorylation. Substrate level phosphorylation. So, during this stage, our 1,3-bisphosphoglycerate, remember we have two, each of them is going to transfer one phosphate group to ADP, forming 3-phosphoglycerate, because they are going to remove the phosphate atom that was previously located on the first carbon atom. So remember, this is substrate level phosphorylation. And one important fact to know is that the substrate here is actually referring to 1,3-bisphosphoglycerate, where it actually donates the phosphate atom to ADP in order to form ATP. And another one thing that I want you guys to note is that during this step, we actually produce 2 ATP. 2 ATP, because we have 2 bisphosphoglycerate. And we produce 2 phosphoglycerate. Please be clear on that. So that's for the 7th step. Now let's get into the 8th step, alright? So during 8th step, remember we had 3-phosphoglycerate. So this 3-phosphoglycerate, right, is actually a very unstable compound. It's very unstable. So now we actually want to stabilize it. And how do we actually stabilize it? Through isomerism, through isomerization. So remember what my partner in crime actually talked about? Isomerization is actually a process of simple rearrangement. So let's see how we rearrange here. Oh, so this phosphate atom is actually moving to the second carbon atom from the third carbon atom. So now are they called? Remember I said that the numbers actually refer to where the phosphate atom located on. So since now they are located on the second carbon, so now they are actually known as 2-phosphoglycerate. Remember, 2-phosphoglycerate. And note that we have 2-phosphoglycerate here. So that's all for the S step. So now we are finally entering our second last step, which is removal of water, also known as H2O. So what happened during this step is that our 2-phosphoglycerate, each of them is going to remove one H2O, forming 2-phosphoenolpyruvate here. You can see, right? We have 2-phosphoenolpyruvate here at the end of this step. 2-phosphoenolpyruvate here. And one thing to know that this phosphoenolpyruvate is actually very unstable. So, why is it unstable? Because you want to promote the next step, very known as substrate level phosphorylation. So now here we are at the last step of our glycolysis. We are finally here. So during this step, substrate level phosphorylation, it is another one of substrate level phosphorylation where we are going to produce ATP. So how do we produce ATP? We are going to donate that phosphate atom that was previously present on the second carbon atom. So where does the phosphate atom actually goes? It goes to the ADP, forming ATP. So at the end of this step, we are going to have two ATP formed, since each of the phosphoenolpyruvate, each of them are actually donating one of their phosphate atom to the ADP outside, forming two ATP, and these phosphoenolpyruvate are being converted into pyruvate, which is the last product of glycolysis. Remember what I said when I was introducing glycolysis? It's the process of breaking down glucose in order to produce pyruvate and energy. So here is our pyruvate. So yeah, that's all for the 10 steps of glycolysis. Isn't it quite long? So since it's so long, right, I'm going to have my partner in crime again to briefly summarize the whole glycolysis process. So the floor is yours, Darshini.
Thank you, T, for such a wonderful explanation from the 6th to 10th step, which seems to be a bit complicated, but don't worry, we got you covered. Okay. So this is a summary of glycolysis. As I said, there are 10 reactions occurring in glycolysis. Let's take a look at all the 10 steps quickly. First one is phosphorylation, isomerization, phosphorylation once again, splitting of 6-carbon sugar, isomerization again. And the 6th step, oxidation and phosphorylation, substrate level phosphorylation, isomerization, removal of H2O, and lastly, substrate level phosphorylation again. So, these are the main 10 reactions happening in the glycolysis process. As you can see, there are few steps repeating again and again. So, how to tackle this glycolysis? If you understand the basics of each and every reaction, for example, what does oxidation mean? What happens during oxidation? What happens during isomerization? What happens during phosphorylation? If you manage to understand all the basics in these reactions, I'm sure it will be easy for you to tackle this glycolysis topic. So, as I said, phosphorylation means what? ATP divided into ADP and phosphate. So, the phosphate will be attaching to the carbon structure present in the particular reaction. That is what we call phosphorylation. So, that's what basically happens in the first and third step. So the sixth step also we have oxidation and phosphorylation. But this is quite unique. Remember, my partner said that we don't take the phosphate from the ATP. Instead, we take the phosphate, inorganic phosphate, from the cytoplasm. So that's what you need to remember for this phosphorylation, okay? And then there are two phases, energy investment and energy payoff. So where does these two phases happening in glycolysis? Remember, I said we have phosphorylation and we are taking the phosphate from the ATP. That means we are investing the energy. The ATP is investing its phosphate. Okay, so that's what we call energy investment. So if they ask where is the energy investment phase, you can say the first step and then the third step where the phosphorylation occurs, ATP breaks down. So if they ask where is the energy payoff, payoff means the ATP invested. So now we need to pay back the ATP that we borrowed just now. So where does this occur? Energy payoff phase. This is where it comes. Substrate level phosphorylation in both step 7 and step 10. Because we are producing ATP. ADP combined with phosphate becoming ATP. So we are paying back the ATP that we used just now in the previous reaction. Okay? And there are a few more steps repeating. Remember, isomerization, it means simple rearrangement occurs. Oxidation, 2 hydrogen atoms are leaving from the carbon structure. So if you understand these basics, you'll be able to answer glycolysis questions correctly. Okay? Before we end this session, let me go to the products. Remember, it is very important to remember the products. Okay? So from 1 glucose, did you hear me correctly? 1 glucose from 1,6 carbon structure glucose, we have 3 products for you. 2-pyruvate, 2-pyruvate, net 2 ATP, and lastly 2 NADH and H+, 2 NADH and H+. So you should see the questions properly. If they are asking for 1 glucose, 2 glucose, or many more. So if they say 1 glucose, these are the products obviously. We hope that you will be able to understand this glycolysis process more by explanation today. Come on T, let's have a final goodbye to our Paul buddies today.
Alright, so that's all for the explanation of glycolysis that we are going to have today. So, thank you everyone for being always during our presentation. Thank you very much.
Thank you for watching this video, and we hope our explanation today helps you to score well in PSPM2 later. All the best. A for biology.